Okay, number 5 on this worksheet, unlike the first 4 problems, is not giving you a polynomial function and asking you to come up with the derivative of it. They're giving you a rational function. And this is where the shortcuts that you guys learned last year in pre-calc, at least the power rule shortcut, which is what most of you guys are using, doesn't really help you out. So we're going to have to do this one the hard way. So using the definition of the derivative, dy dx is equal to, we have a limit here as h approaches 0. And I tell you what, guys, since we're starting to get good at this, I'm not going to write the formula out. I'm just going to dive right into it. We begin with f of x plus h. So we take the original function right here, and everywhere there was an x, we replace it with the binomial x plus h. So that's going to give us a 2 over, and the x becomes an x plus h, and there's a plus 3 at the end of all that. So that, I usually put brackets right there, although it's really not necessary here, that's the f of x plus h. Minus, then there's going to be an f of x right after that, and f of x is just the original function, unchanged, 2 over x plus 3, and then that's all going to be over h. So that's the setup here, guys, and that's the limit that we now need to evaluate. And sure enough, plug and chug doesn't work because, as always, you end up with 0 on the bottom. I should say, as always, in definition of the derivative problems. So how are we going to get around this? We are going to need to get a common denominator in the numerator there, guys. So to do that, I'm going to switch to green here, I think. Actually, I'm going to go purple. I lied. Okay, what I'm going to do is multiply the first fraction right here by this denominator over itself, x plus 3 over x plus 3. So I'm multiplying the first fraction by the second fraction's denominator, top and bottom. Then I'm going to do the same thing here. I'm going to multiply the second fraction by the first fraction's denominator, x plus h plus 3 over itself, x plus h plus 3. Okay, so where is that going to get us? Let's take a look at what we've got here. This equals now a limit as h approaches 0 of, and let's see what we got. I'm distributing the 2 backwards into that x plus 3. So, yeah, I'm going to go right into this, guys. That's going to give us a 2x plus a 6. Now you'll notice I'm not putting a fraction within my numerator like you might have expected. You'll see how I'm going to handle that in just a second. Then what we're doing here is we're taking this 2 right here, which is actually negative 2, you guys, and distributing that into this trinomial. So that is going to be a minus 2x, a minus 2h, and then a minus 6 at the end of all that. Okay, now, the denominator of the numerator, which comes from this line right here, you guys, moves into the denominator of this overall fraction. And that I'm going to leave factored as x plus 3 times x plus h plus 3. And I'm really hoping that everything there that's problematic will cancel out, and I won't have to multiply out a binomial times a trinomial, because that's no fun. Okay, so we've got that. The only thing I haven't covered is this h right here, which was the numerator of the denominator, and that just goes in that same line where it was down in the denominator. You could have put that in the front out here or in back, wherever you wanted to do it. Now, have we made any progress? Well, I certainly hope so. Let's see what happens in the numerator. The 2x and the minus 2x cancel. A plus 6 and a minus 6 cancel each other out. And we're now left then with just a minus 2h up in the numerator. And since that's the only term that's left in the numerator, this h right here can cancel out with this h right here. And that, you guys, I think is what we were waiting to have happen. I think we got it already. So where are we then? If that h canceled in the top, we're left with a negative 2. Then we've got an x plus 3 times an x plus h plus 3. And we can now let h actually become 0. That really only applies right here, but I think that's going to get us something that's a little bit better than we might think. Guys, let me make a little line right here. Okay, so what does that do for us now? This is now going to equal, and I think we can make this substitution so I don't need the limit anymore, negative 2 over, we're not doing anything at all with the x plus 3 out in front, and that h in the second factor there, the trinomial, becomes 0. That's x plus 0 plus 3, which is just going to get us negative 2 over an x minus 3 times another x plus 3. think I said minus, sorry, plus. So we're going to have an x plus 3 quantity squared down there in the numerator, and that, you guys, is our derivative here. dy dx is equal to negative 2 over x plus 3 quantity squared, and that is our answer there for problem number 5.